Here's our last video of this section. So we're going to put it all together. We're going to sketch these graphs using everything we know. We can find out where a function's increasing, we could find out whether it's concave up or concave down. We can find maxes and mins. We know end behavior. We have all that stuff from pre-calc that we know. So we're going to take a look at each of these. So I'm going to note first in this one, the domain's all real numbers. If you hear some squeaking this time, Zoe now has her other toy, so don't worry about it. No big deal. All right. So I'm going to just start out by finding out the first derivative. I want to know where it's increasing, decreasing, or whether it's constant at all. So as I take the first derivative, okay, I'm going to be looking for critical values. If I factor out least powers here, probably will give me my easiest way. So I get x. Oh, wrong part. All right, x to the 1/3 minus 2. So we're going to try to figure out where this part is equal to 0. So our first term, x equals 0, and the second term, we have x to the 1/3 equals 2, cube both sides, x equals 8. So these are our critical values. We'll plug them in. 0, 8, x, we're plugging them into the first derivative. Pick some numbers in between it. So -1, if I plug that in, it's positive. 1 is negative. 10 is positive. So this tells me a lot. I have a relative max at x equals 0. I have a relative min at x equals 8. I'm increasing from negative infinity all the way to 0, and again from 8 to infinity. And then I'm decreasing from 0 to 8. So that's about all the first derivative can tell me. So I'm going to go ahead and analyze the second derivative now. So we have 29ths x to the negative 1/3 minus 29ths x to the negative 2/3. Factor out my least powers here. Got 29ths x to the negative 2/3. And I'm left with x to the 1/3 minus 1. Figure out where that equals 0 or it's undefined. It's going to be undefined when x is 0. And it's also going to have a possible inflection value when x is 1. Plug those in on a number line. We got 0, we got 1. This time we're plugging them into the second derivative. Let's see, 1/2, 2. Negative, negative, positive. Oh, this tells us a ton. We have concave up like a cup from 1 to infinity. We're concave down like a frown from negative infinity all the way to 1. We have an inflection point at x equals 1. So now if I go to try to pull this graph, I'm going to need some points. So I'm going to plug in, how about 0? That's a nice easy one. Oh, 0. I'm going to plug in something that I know I could take the cube root of. So I'm going to plug in 8. And I believe I get negative 16. Alright, so 0, 0 is my point. 8, negative 16 is a point. Alright. Got a relative max at 0. I am increasing up to 0, then decreasing. I'm concave up until 1. Yeah, all the way until 1. So concave up, there we go. From 0 to 8, I'm decreasing, but I'm going to start to become concave down like a frown. And then I have concave up like a cup again. So this gives us a good idea of what f looks like in the first example. So you can see that this takes a little while. You can do lots of things. You can find x-intercept, y-intercept, slant asymptote, vertical asymptotes, holes, whether it's even, odd, neither. So I would like you guys to pick either, no, you know what? I would like you to do letter B, and we'll do letter C in class. Alright, you don't need to put anything in your whisk. I just want to see that it's done. So this, I'd like you to do for homework, okay, before the class starts, and then C we'll do in class.